Good morning, this is Kasturi Day. Today I am going to discuss the air chapter according to ICSE syllabus class 7. It's a chemistry chapter. Air. We know that air consists of mainly nitrogen and oxygen. So nitrogen and oxygen are the main constituents of air. Nitrogen consists of 78% and oxygen is 21% of the air is oxygen and 78% of the air is nitrogen. And the other constituents which are present in air are carbon dioxide, water vapor, argon and other inert gases, ozone, dust, smoke, even sulfur dioxide, hydrogen sulfide, nitrogen dioxide, etc. are also present in air. These all other constituents, that is carbon dioxide, water vapor, argon, inert gases, ozone, dust, smoke, sulfur dioxide, hydrogen sulfide, nitrogen dioxide and any other gases which are present in the air consist of only 1%. Okay. So carbon dioxide in air is present in about 0.03%. Only about 0.03% of air is carbon dioxide. And argon and inert gases are only 0.93%. Okay. So these are the constituents of air. Now during ancient times, air was considered as an element. But now it has been proved to be a mixture. And this was been proved by Antoine Lavoisier in 1774. He proved that the main constituents of air are nitrogen and oxygen. He did an experiment with a bell jar and mercury. Okay, he used a retort in which mercury is poured and he heated that mercury in that retort, and he also used a trough in which a bell jar was inverted and the trough contained mercury, and this bell jar was graduated, okay, 0 to 5. After heating the mercury, he found that the air which has been inside that this retort, it was used up by the mercury to form mercuric oxide. Okay, it had red mercuric oxide that formed, and when the oxygen was used up, the trough which contained mercury, the mercury inside the trough, that it rose into the bell jar to 1/5 of the mark of the graduation of the bell jar. Okay, and this rise in the level of mercury is because the air which was in the retort has been used up by the mercury to form mercuric oxide, and this mercuric oxide contained oxygen. This oxygen was used up by mercury. So 1/5 of the air is, he proved that by this experiment, he proved that 1/5 of the air is oxygen and the 4/5 of the air is nitrogen. Okay, which did not support burning, but oxygen support burning. Okay. His observations, he saw that a red layer of mercuric oxide was formed on the hot surface of mercury in the retort. The level of mercury in the trough rose by 1/5 of the total volume of the bell jar. Now he concluded that 1/5 of the portion of air in the bell jar used up by mercury in the retort to form mercuric oxide, that is active air. This air which formed this mercuric oxide, that is active air, he named it as active air. Okay, if mercuric oxide is strongly heated, it gives back this mercury and oxygen, separated it. Now this gas supported burning, but better than the air, and it supported life. And now he named this active air as oxygen. Okay. Now the rest is 4/5 portion of the air in the bell jar, that is inactive air. He named it as inactive air, and this air did not support burning, nor it supported life. he named this air, this 4/5 of the air which was present in the bell jar, as azote, which means unsuitable for life. Later it was named as nitrogen. Okay. Now, air is a mixture. I told you previously, in the ancient times, air was considered as an element, but later on it was proved that air is a mixture, okay, and not a compound. Why? Because composition of air is not fixed. Okay, it varies from place to place and from time to time. The components of air retain their individual properties, like oxygen, which is present in the air, continues to support combustion. That's a property of oxygen, which when it is separately used, that also supports support combustion. And when it is mixed with air, when it is present in air, that also has the same property. Okay. So we know when we studied that element, compound and mixtures, we knew that compound has a very different property from the element. But in the mixture, the constituent of the elements, the elements which are there present in the mixture, they have their original properties. But in the compound, as a new substance is formed when mixing, when they are chemically combining, so they have a very different separate property than that of the constituent elements. Now, liquid air has no definite boiling point, because the constituents of the air, the constituents of the air have their different boiling points. So, the liquid air has no different boiling point. No energy exchange occurs when the components of air are mixed with each other, as there is no particular chemical combination taking place and no new substances formed. Therefore, when they are mixed together, the components of air, there is no energy exchange. Then components can be separated by simple physical methods. It involves their liquefaction followed by fractional distillation to separate the constituents of air. Next we come to that air is not represented by any chemical formula as it is a mixture. Okay. Then an artificially prepared mixture of oxygen, nitrogen, carbon dioxide, etc. in the same proportion as that present in the air, they also behave as the same manner as that of the air which is found in the atmosphere. Now, oxygen. In atmosphere, we know that oxygen concentration in the atmosphere is 21%. Okay, by volume, and 23.2% by mass. Also, oxygen in atmosphere present in the atmosphere in the form of O3, that is ozone. Okay, ozone, in the form of ozone also oxygen is present in air. Now, oxygen in air, water present in air, water, animal, plant tissues, in the minerals, etc. in the form. About 89% by mass of oxygen is present in water. Okay. Then in the human body it is present as 65% by mass. Then in plants they contain oxygen by mass is 60%. And in the earth's crust, in the form of oxides, carbonates, silicates, etc., oxygen is present about 50%. And also it is an essential component of carbohydrates, proteins, fats, nucleic acids. Okay. Now, how do we prepare oxygen? Mainly, there are two processes by which oxygen is prepared. Okay. From hydrogen peroxide. Hydrogen peroxide at room temperature, it breaks into water and oxygen in the presence of a catalyst, that is manganese dioxide, MnO2. Okay. Now, if we take hydrogen peroxide in a flask and we heat it, we add in room temperature also we can see that it changes to water. So this is a very suitable process, okay, and this manganese dioxide is poured through it, this funnel, and we see that a gas escapes in the trough, okay, and it rises into the inverted flask, okay. So we see that bubbles rising up and taking place above the water level, okay. The gas pushes the water downwards and collects at the top of the inverted jar. This is known as downward displacement of air. Downward displacement of water. Okay. Now also another preparation is through potassium chlorate, KClO3. Here it has to be heated. Potassium chlorate, if it is heated in presence of the catalyst MnO2, we see that KCl is formed, that is potassium chloride is formed, and oxygen is liberated. This is also collected as downward displacement of water at the top of the inverted jar. In MnO2, if MnO2 contains any carbon particles, both will be black. Okay, carbon particles are black, and MnO2 when burned, that is also black. So the mixture will explode. So it is required to remove these carbon particles by heating MnO2 alone in a pot strongly. Now carbon forms carbon dioxide and it escapes, and what remains is MnO2. That's pure form of MnO2, and that is used as catalyst for these two processes, that is to separate oxygen from hydrogen peroxide and to get oxygen from potassium chlorate. Okay, now some compounds, common compounds which contain oxygen are oxides, carbonates and sulfates. Oxides in the form of silica, which is a sand, silicon oxide. Then hematite, which is an iron oxide, iron ore. Bauxite, aluminium ore, it is Al2O3, 2H2O. Carbonates in the form of limestone, calcium carbonate contains CaCO3. Then sulfate, it's a gypsum salt. It contains calcium sulfate, CaSO4 dot 2H2. It's a hydrated calcium sulfate. Okay, so I stop here. I'll continue with the rest of the chapter in the next video. Please go through this. If you have any doubt, please do write in the comment box, and you can also suggest me how to improve my videos so that you can like it much better. And if you like the video, press the like button. And if you are a new viewer to my channel and not subscribed yet, please do subscribe to get the notification of my next video. Thank you.